When you multiply any factor, you have to divide the same because the value of the determinant should not change. When any one side or both side of the elements above or below the principal diagonals are 0, then the value of the determinant is just the multiplication or just the value of the principal diagonal elements. They have given the value of the determinant is equal to 0. We need to find the value of x. Hello everyone, a warm welcome to one and all. This is Vidhyaashram ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in last session, we were discussing the problems related to the determinants. So here we'll continue the same. So let's look at the first question here. Prove that a square bc ac plus c square, a square plus ab, b square ac, ab, b square plus bc, c square is equal to 4a square b square c square. So look at the determinant here. In the first column, you can see a as a common factor. In the second column, b as a common factor. Third column, c is a common factor. So you can remove the common factor. So if you take this as LHS, taking a, b, c from the first, second and third column, we will get the determinant here. A plus B, AB. Here, C, B, B plus C. Next, A plus C, A, C. What I'll do next here is, I will rewrite R2 dash as R2 minus. Since we have taken A as a common factor, here we have left with B. So what I will do here is, I will subtract from R1 plus R3. Because you can see A plus B, you will get it as A plus B here. So if you want, the new R2 can be taken as R2 minus R1 plus R3. So it will be minus A minus B. So it will become completely 0. So what happens then? Outside you have A, B, C. So write the first row as it is A, C, A plus C. Second one becomes 0. What about third one? B minus B minus C. Again it becomes minus 2C. So here you will get it as minus 2C. Next, A minus A plus C plus C. A minus C get cancels and you are left with minus 2C again. So minus 2C. And the third row, write it as it is. Now look at the second row here. You have minus 2C as a common factor. Take it outside. So if you take minus 2C outside, it becomes minus 2A B C square. So here then A, C, A plus C. 0, 1, 1. Here B, B plus C, C. So this is the new determinant we have got. So next what I will do here, R3 as R3 minus R1. So if I do it, I will get it as minus 2A B C square. Write the first as it is A, C, A plus C. Second as it is 0, 1, 1. Third is R3 minus R1. So that is B minus A. And B plus C minus C becomes B. And C minus A minus C becomes minus A. Next, I will continue the operation with respect to columns. I will take the new column C2 as C2 minus C3. So what happens? It is minus 2A B C square. Write the first column as it is. That is A0 B minus A 0 B minus A. Second column, take it as C2 minus C3. So that is C2 dash, I am taking it as C2 minus C3. Let's see C minus A plus C. then it becomes minus A here. Next, 1 minus 1, 0. Next, B minus A, minus of minus A becomes B plus A. Next, write the third column as it is, A plus C, 1 minus A. A plus C, 1 minus A. Now, expand the column using the second row. So, clearly you can see here minus 2ABC square, expand the determinant. So, this is minus plus minus. So, minus 0 into anything, whatever, deleting the row and column, multiply whatever the factors you have, you will get the value as 0. Plus 0 into anything, again deleting the row and column of 0, you have a factors which will become 0. So, that is 0. Next, the last one is minus 1 because the sign of the second row is minus plus minus. So, therefore, the sum or expansion will be in the form of minus plus into minus. So, now deleting the row containing 1 and column containing 1, we have the factors as A into B plus A minus B minus A into minus A. So, we have outside minus 2AB square. So, this becomes 0. Minus into minus plus becomes 2ABC square. So, here it becomes AB plus A square minus. So, here minus AB minus into minus plus A square minus A square. So, here again plus. Outside we have plus A square minus A square cancels. 2ABC square into 2AB. So, multiplying 2 2s are 4, A square, B square, C square. So, this is what the value of the determinants we need to prove. 4A square, B square, C square. So, next we have prove that A square plus 1, AB, AC, AB, B square plus 1, BC, CA, CB, C square plus 1 is equal to 1 plus A square, B square plus C square. So, here consider the left hand side of the determinant here. So, here multiply column 1 by A, column 2 by B and column 3 by C. So, what happens column 1 when you multiply? It becomes A square plus 1 into A. Here it is A square B and CA square. Next here it becomes AB square. Next here B square plus 1 into B here. Next CB square. Next here this becomes AC square, BC square, C square plus 1 into C. So, this is the new determinant I will get. When you multiply any factor, you have to divide the same because the value of the determinant should not change. So, when you are multiplying A, you should divide it by A. When you are multiplying B, you should divide it by B. When you are multiplying C, you should divide it by C. So, taking A, B, C as a common factor, then if you divide by A, B, C, you will get back the same one. Now, consider row now. Look at the first row, A is a common factor. Second row, B is a common factor. Third row, C is a common factor. Again, taking A, B, C from row 1, row 2, row 3. Next, taking A, B and C from R1, R2 and R3. So, that is you can take A, B, C as a common factor. Outside you already have A, B, C. From the first row, if you take A outside, it is A square plus 1, B square, C square. Next you have A square, B square plus 1, C square. Next you have A square, B square, C square plus 1. Next, you can cancel it. So, this is the new determinant you got. Next, see here, add all the elements of each column to the first column. That is C1 dash can be taken as C1, C2, C3. Then what happens? 1 plus a square plus b square plus c square. 1 plus a square plus b square plus c square. 1 plus a square plus b square plus c square. Next here it is as it is, b square plus 1, b square, c square, c square, c square plus 1. You can take 1 plus a square plus b square plus c square outside. So then you have 1 plus a square, b square plus c square. If you take it as common factor, the first column become 1, 1, 1. So the second column is b square plus 1, b square. The third column is c square plus 1. Next, I will take R2 dash as R2 minus R1, R3 dash as R3 minus R1. That is the new row and row 2 and new third row. So that is outside you have 1 plus a square plus b square plus c square. Write the first row as it is 1 b square c square. So R2 is R2 minus R1. 1 minus 1, 0. B square plus 1 minus b square, 1. C square minus c square, 0. 1 minus 1, 0. B square minus b square, 0. And here it is 1. So clearly you can see this is your principal diagonal and the elements under the principal diagonal are 0. So using the property of the determinant, if any one side of the principal diagonal elements are 0, then the value of the determinant is product of the principal diagonal. So here the principal diagonal element is 1 into 1 into 1, so which becomes 1. So therefore 1 plus a square plus b square plus c square into 1 we can directly write. So that is equal to 1 plus a square plus b square plus c square. So that is the RHS of the given determinant. Prove that a minus 2b minus 2c, 3b, 3c, 3a, b minus 2c minus 2a, 3c, 3a, 3b, c minus 2a minus 2b is equal to 4 times a plus b plus c whole cube. So here, let me add all these 3 column elements to the first column. That is C1 dash is C1 plus C2 plus C3. What happens? Minus 2b plus 3b, b, minus 2c plus 3c becomes c. So the first column becomes a plus b plus c, a plus b plus c, a plus b plus c for all the elements. And write it as it is 3b, b minus 2c minus 2a, 3b. Here again 3c, 3c, c minus 2a minus 2b. Now take a plus b plus c outside. So the result 1, 1, 1, 3b, b minus 2c minus 2a, 3b. Next 3c, 3c, c minus 2a minus 2b. So next I will take R2 dash is equal to R2 minus R3 and R3 dash is equal to R3 minus R1. So let's see now what happens. A plus B plus C, and here write the first row as it is. R2 dash is R2 minus R3. 1 minus 1, 0. So next is B minus 2C minus 2A minus 3B becomes minus 2C minus 2A minus 2B. And here again 3C minus C minus 2A minus 2B becomes 2C minus 2A minus 2B. Next, R3 dash is R3 minus R1, 1 minus 1, 0. And here it is again 0. So next it becomes 0. So here also 0, 0. So again here if you can take minus 2C minus 2A minus 2B. So now expand this, you will get A plus B plus C. And you can clearly see this is equal to 0. So you can directly write it as a product of two principal diagonals, that is 1 into, you can take minus 2 as a common factor, A plus B plus C, into again minus 2 as a common factor, a plus b plus c. So by multiplying we will get 4 into a plus b plus c whole cube. So this is the answer. Next, R3 minus R1 is 3c minus c becomes 2c minus 2a minus 2b. So next is 0, 0. So c minus 2a minus 2b becomes minus 2a minus 2b minus 2c. Clearly you can see this is the principal diagonals and elements below the principal diagonals are 0. So using the determinant property, what does it say? When any one side or both side of the elements above or below the principal diagonals are 0, then the value of the determinant is just the multiplication or just the value of the principal diagonal elements. So therefore I can directly write this as a plus b plus c 1 into this and this, which becomes 2 times minus 2 into a plus b plus c into again here minus 2 into a plus b plus c. So minus 2 into minus 2 becomes 4. A plus b plus c, a plus b plus c, a plus b plus c 3 times, which becomes a plus b plus c whole cube, and that is equal to the right hand side of the given result. Hence, we have proved it. So next we have 1 a plus b, a square plus b square, 1 b plus c, b square plus c square, 1 c plus a, c square plus a square. So here I'll do R2 dash is R2 minus R1 and R3 dash as R3 minus R1. Then I'll get the determinants as 1 as it is a plus b, a square plus b square. 1 minus 1, 0. So b plus c minus a minus b becomes c minus a, c square minus a square. Here R3 minus R1, 0. So c plus a minus a becomes c minus b, c square minus b square. So in the second row, c minus a is a common factor. In the third row, c minus b is the common factor. Taking it outside, c minus a and c minus b. So the first column is 1, 0, 0. Second column is a plus b, 1, 1. Next is a square plus b square. So we have c plus a and c minus c plus b. Now we can expand the determinant using the column. So c minus a, c minus b into 1 into c plus b minus of 1 into c plus a, which becomes minus c plus 0 plus 0 again, because we have two factors multiplying with 0, which becomes 0. So plus c minus c cancels, we have b minus a. So c minus a, c minus b, b minus a. From the last two factors, taking minus outside, we get a minus b, and this is b minus c, and the last we can put c minus a. That is the RHS of the given determinant. Next question. Solve 3x minus 8, 3, 3, 3, 3x minus 8, 3, 3, 3, 3x minus 8 is equal to 0. So here they have given the value of the determinant is equal to 0. We need to find the value of x. So using the same methodology, here we are going to find the value of x. So let's see here. So let me take c1 dash as c1 plus c2 plus c3. So then it becomes 3x minus 8 plus 3 plus 3, which becomes 3x minus 2. So the first column becomes 3x minus 2 for all. Then it is 3, 3x minus 8, 3, 3, 3, 3x minus 8. Let me take 3x minus, this is given, this is equal to 0. So let me take 3x minus 2 common outside. Then it becomes 1, 1, 1, 3, 3x minus 8, 3, 3, 3, 3x minus 8 is equal to 0. Next, row operation, that is R2 dash as R2 minus R1 and R3 dash as R3 minus R1. So then it becomes 3x minus 2. Here 1, 3, 3. So 1 minus 1, 0. 3x minus 8 minus 3 becomes 3x minus 11. 3 minus 3, 0. Next, 1 minus 1, 0. 3 minus 3, 0. 3x minus 8 minus 3, 3x minus 11. That is equal to 0. So here clearly you can see the elements under the principal diagonals are 0. So I can write this as 3x minus 2, 3x minus 11 into 3x minus 11 is equal to 0. So equating this, we get 3x minus 2 is equal to 0, 3x minus 11 is equal to 0. So therefore, I can write 3x is equal to 2, 3x is equal to 11. So x is equal to 2 by 3 or x is equal to 11 by 3. So this is the value of the x. Next, x plus 2, 3, 4, 2, x plus 2, 4, 2, 3, x plus 4 is equal to 0. Same. So let me take column 1 as sum of all the columns. Then I will get x plus 9, 3, 4. X plus 9, x plus 2, 4. X plus 9, 3, x plus 4 is equal to 0. Take x plus 9 as a common factor. Then 1, 1, 1, 3, x plus 2, 3, 4, 4, x plus 4 is equal to 0. X plus 9, row operation we can do. Write first column as it is. Second column as R2 minus R1, 0. So x plus 2 minus 3 becomes x minus 1, 4 minus 4 is 0. R3 minus R1, 1 minus 1, 0. 3 minus 3, 0. X plus 4 minus 4 is x is equal to 0. Again, we got the value under the principal diagonals are 0. So I can directly write it as x plus 9, x minus 1 and x is equal to 0. From these three observations, we can put x plus 9 is equal to 0 or x minus 1 is equal to 0 or x is equal to 0. So here we get x is equal to minus 9 or x is equal to 1 or x is equal to 0. So these are the values of x. Next, 2 plus x, 3 minus 4. The same kind of operation here. Let me add 2 plus 3 is 5, 5 minus 4 is 1. So x plus 1. Next, x plus 1, x plus 1. So we have 3, 3 plus x, 3. Minus 4, minus 4, minus 4 plus x is equal to 0. Take x plus 1 as a common factor. Then we get 1, 1, 1, 3, 3 plus x, 3, minus 4, minus 4, minus 4 plus x is equal to 0. Now row operation R2 minus R1, R3 minus R1, x plus 1 is 1, 3 minus 4. Here 0, 3 plus x minus 3 is x, 0, 0, 0, minus 4 plus x minus 4. That is minus of minus 4 becomes plus 4. Again here it is x is equal to 0. Clearly you can see it is x plus 1 into x is equal to 0. So I can write x plus 1 is equal to 0, x square is equal to 0. This implies x is equal to minus 1 or x is equal to 0. So this is the value of x. So for your examination, they may ask you to prove the properties of determinants in the form of the prove that or show that question, or they may ask you to find the value of x whenever the determinant of value is 0. So these kind of question carries 3 marks in your examination. Thus, we have understood how to evaluate any determinants with the help of its properties. We will meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.